you got it worked out now, haven't you? Oh, John. Okay, that's okay. Right. I'll share my screen, which is the notes initially that I sent you, and we'll work our way through. I suppose before we start, has anyone got any specific questions or about kitchen ventilation?
I think the new standard, the 1668 Part 2, focuses a lot on this. There was a presentation not too long ago about the updates. So,
2024.
Yeah, 2024. Yeah.
Right. Okay. I haven't actually looked at that, to be honest, but I suppose I'd better do that. But that was one thing I wanted to talk to you about. Kitchen exhaust is highly regulated, like a lot of other things that we do, by the NCC, AS 1668 Part 1 and 2 specifically. And with the NCC, part of the idea that I've got with these sessions is to get you familiar with the codes and the way they all work together, or which one's relevant, and where you need to look. Sorry, I've got some background noise here. Is that coming through?
No.
He's going down the road. They've been mowing the lawns outside, and he's walking down the street with a blower. I think he's going away now, so that's all right. So the NCC, firstly, F6D12, this is Part F of, or F6 of the NCC talks about light and ventilation, and so we're interested in ventilation. So there's always this to be aware of, Part F, and this talks about a commercial kitchen must be provided with a kitchen exhaust hood under these conditions, a total maximum electrical power input exceeding 8 kilowatts, or total gas power input exceeding 29 megajoules an hour. Those numbers probably don't mean much to you, but basically that's saying we're talking about a commercial kitchen system, because in a domestic kitchen you don't have anything like those energy consumption rates. So that's pretty much all it says. But just on the NCC, if we just dwell on that for a moment, if I go back to the index, I'll go and find the index. Okay, now I want you, as part of this training, to get familiar with using the NCC, and I know that you talk about it every day, but Part A4 is called referenced documents. The NCC, whenever it comes out, it refers to other documents, which principally are Australian standards, but there's other things as well. So when you're dealing with a project, and let's say we're dealing with NCC 2022, you need to look at these reference documents. Now, if you go through the process, you'll find that this refers to Schedule 2. And just to save time, I know where Schedule 2 is. It's on page 603. So I'll just go to that. And here we are. So this is, go back to the start of that. This is referenced documents. You'll find links in there if you want to find where these documents are. But as I said, just to save a bit of time. So if a document is referenced in the NCC, then it applies, okay? It's that particular standard that applies. So you can see here, AS 1668 Part 1, 2015, AS 1668 Part 2, 2012, Part 4, 2012, etc. So this particular NCC, if you're doing a job at the moment which has kitchen ventilation, then you can use AS 1668 Part 2, 2012, or you can use 2024 if you want to. So at the moment, there's this transition period where you can use one or the other. Is that clear? This doesn't happen all that often, but it does happen from time to time. And the same thing happens with the NCC. If it's let's say they update it next year, there'll be a transition period where you can use one or the other. So that's I just wanted to make that point, and to show you that this schedule exists and you need to be aware of it. Now, you might find that some documents are not referenced in here, and therefore, say for instance, AS 2107. Now, see if you can find that. We go down and it's not there. Does anyone know what AS 2107 is? Okay, well, I don't expect you to, but it happens to be the Australian standard for acoustics or acoustic recommendations for different types of spaces. And we're going to talk about that probably in a couple of weeks' time. But it's not referenced in the NCC. So that means that it's not mandatory. Okay. If it is referenced in the NCC, it is mandatory. If it's not mandatory. So AS 2107 in this case is a recommendation. This is how they would recommend you do it, but doesn't mean you have to. Okay, we'll go back to the notes again. So AS 1668 Part 2 in Section 3 talks about exhaust ventilation and mainly talks about kitchen ventilation. So we'll have a look at that. Excuse me. So it's mechanical ventilation exhaust systems. There's a flow chart there you can refer to, but we want to just skim down to firstly 3.3 local exhausts, types of effluent requiring local exhaust. So there's type A and type B. Type A is basically your sort of industrial processes like welding, so explosive dust or fumes or vapors. We don't do a lot of that sort of work, but occasionally we do. And I know Jess had a welding exhaust job recently. So that would come under type A. Okay, and that has some specific requirements. But type B is basically kitchen ventilation. And this clause here is basically verbatim what I just showed you in the NCC. So anything that's got 8 kilowatts of electrical energy or 29 megajoules per hour of gas energy requires local exhaust. So that's something that's, we're just talking about commercial kitchens. A commercial kitchen will have this. So it's just to give you a bit of background to it. And then there's AS 1668 Part 1, which we'll come to a bit later on. So as I said, clause 3.3 specifies type of effluent requiring local exhaust. Some exemptions are given. And so if we go back to 1668 Part 2, oh, where are they? This is the thing, and they're all over the place. All right, look, we'll come to that later. Sorry, the following, here we go. The following shall be exempted from this requirement. And so there's a few things there that don't have to have a kitchen hood, basically, is what we're talking about. If it comes under this clause, then you need to have an exhaust hood over the cooking equipment. However, some things are exempted. Commercial coffee machines, so you see coffee machines sitting on benches in cafes, they don't need a hood. They're exempted. Microwave cookers or similar sort of things don't need to have a hood. And one of the ones mentioned here, apparatus used solely for domestic purposes. So they don't have to have this commercial type of hood, and that's, we all know that. You don't have them in your home. But most apartments and new homes have a range hood, which you would have seen, I suppose. I can show you a picture of one of those. That type of thing, where the tray comes out with the filters in it and the lights come on and they go over your stove in your home. So you will come across these if you're doing apartments, and there's a bit of information in here. This is a Westinghouse brand, which is quite common. 340 cubic metres per hour extraction capacity, which is about 100 litres per second. So that's something to keep in your memory banks. That's about the flow rate required. Now, clause 332 of AS 1668 Part 2 specifies requirements for effluent removal, and 3323 specifies that kitchen exhaust hoods shall be provided for type B effluent. 3324 states that grease filters shall be provided when the effluent contains grease vapour. So the standard commercial kitchen hood will have grease filters to try and trap as much grease as possible before it enters the ductwork and goes through the whole system. So you try and stop the grease getting through the duct, but some will go through, and over time that will build up in the ductwork. Clause 3, 4 and 3, 5, kitchen exhaust hoods. These two clauses specify requirements for the design of kitchen exhaust hoods. Have any of you guys had to do this yet? Design an exhaust hood?
Not yet.
No, I imagine not, but it's something that's probably going to crop up at any time. It just depends on the type of work you get. If you have say a restaurant or like a shopping centre which has got restaurants in it or cafes, and they've got commercial cooking areas or commercial kitchens, there will be exhaust hoods, and it's quite common for us to have to do that. So so that's the types of hoods, and the calculation procedures are given in these clauses, and we can have a quick look in a minute. Just to note as well, there are alternative exhaust hood designs. So deemed to satisfy is to use the AS 1668 Part 2 methods, but there are manufacturers who make alternative designs and even engineered ventilated ceilings. They're not very common, they're very expensive and very fancy. I've never actually worked on one, but they are available. It would be on a very big project, a high quality hotel or something like that. These alternative designs have some benefits. They're very expensive, but quite often an architect or kitchen designer may want this type of thing over the kitchen equipment. And the benefit of them from a mechanical point of view is that they normally have quite a bit less requirement for airflow. So they've been tested and proven to work effectively with much lower airflow rates than what you would get for an AS 1668 design. Okay, but there's a cost involved, a large cost. So that's just something to keep in mind. So, but normally that will be presented to you. That won't be something that we will offer. The builder would say, we're going to use let's say a Holton exhaust hood, model such and such, and then they'll provide you with details of the airflow rate requirements and the pressure drop through the hood, and then that will become part of our design to incorporate that into the mechanical design. So in this section 3.4, kitchen exhaust hoods, it goes through 7 different types of hoods, common hoods. There are others. I mean, these are just the standard types of hoods. And then there's different types of cooking processes. Again, there's 7 cooking processes shown. It also talks about hoods serving non-grease producing equipment. So this would normally be a dishwasher hood. In a commercial kitchen, you normally have all your fryers and ovens and whatever they use in there, griddles. But there's quite often a dishwasher as well. So a dishwasher does need to have an exhaust hood over it because it's producing vapour and heat, and that needs to be taken away. But a dishwasher hood does not need filters. It's just an open hood to take away the steam and heat. So there's reference, you can see here, reference to Appendix E all through here, and this gives you different styles of hoods. I'll just go to Appendix E and show you some of those. So I'm not going to try and go through all this stuff. If it comes up, you're going to have to go through this and work out what you need to do. But this appendix shows different types of hoods. So this one, first one here, is a typical low side wall. That's obviously an elevation or section here. The most common ones that we would use would be type 2 and type 3 and type 4. So type 2, you might see this, to give you an example, in a cafe or say a fish and chip shop. If you go and buy fish and chips, the hood is usually right in front of you because they're cooking the fish and chips in front of you, and they will always have a hood. So it would look something like this. This particular one has got a wall on the side, which is quite common for that type of shop. And then type 3 is basically the same type of exhaust hood, but there's no wall on the side, so it's in the middle of a wall. Type 4 is an island style where it's in the middle of a room, which is quite common in commercial kitchens, and you may have cooking equipment on both sides. So, and that's why there's grease filters on both sides there to take out the grease as it's going through. And there's an oven, typical type of hood for an oven. That's a pizza oven. Another oven, pastry oven or something like that. Here's a typical dishwasher type hood, and so on. So there's various types, and in the standard, it tells you how to calculate the flow rate and how to design the hood. So we're not going to go through that now because that's quite a big exercise in itself, but just know that you can follow through that and get some help from your colleagues and work that out. Now, exhaust air clause 3.7 shall not be recycled to other enclosures of different use. Now, this is obvious. The exhaust from a kitchen has to go outside. It doesn't get discharged into some other adjacent space. Having said that, I have seen this done. It wasn't, we were called in to do a job. I was in Cairns, actually, in Queensland. I was up there for a while doing some work on different jobs, and there was a hotel that was doing renovations to a kitchen. And so we had to modify the exhaust systems. And when I looked at the existing kitchen exhaust, and then I went up onto the roof. They had a low-level roof above the kitchen area. I couldn't find the exhaust fan. So I came back down again. I'm hunting around for it, and I got up in the ceiling, and there it is. It was discharging into the room next door in the ceiling space, and the fan was in the ceiling. Now, that's how they got away with that. I don't know. It was obviously a renovation that nobody approved. It was just built, but anyway, that's an extreme fire hazard. So anyway, we fixed that up. It's very unlikely that will happen. Normally, the exhaust will be to the outside in a suitable location, which we'll go through shortly, because that's regulated as well, of course, where you can discharge to, and proximity to boundaries and other things in the building. Now, the air pressure within the kitchen area has to be designed to be a negative pressure, so less than that of adjacent enclosures. And you're familiar with this sort of concept now, that exhaust needs to be greater than the supply, because what you don't want to pressurize the kitchen area, have a positive pressure to surrounding areas, because then you can have leakage from the kitchen into those areas, and the smells will go out with it. So yeah, this is to ensure that contaminated air doesn't migrate from the kitchen area into adjacent areas. So typically what you would do is have supply air to the kitchen, or it might go directly to the hood, and then that gets exhausted out, but you have your supply air lower than the exhaust, and the makeup can come from, there might be a dining room or a servery area or something like that. You can get your makeup from there, allow that to leak into the kitchen and exhaust out so that you haven't got the kitchen odours getting out. The clause 3.8, replenishment of exhaust air. Again, this is the supply air to the kitchen, or the makeup air has to be of an acceptable quality. Acceptable quality is defined in AS 1668 Part 2. But basically, again, it's what we're talking about is air that is suitable for the application. So obviously, if you're bringing fresh air into a kitchen, it needs to be clean. If you go into, I'll use that fish and chip shop example again. When I've been into them, I've been a bit more horrified, I suppose, for want of a better word, to see where the makeup comes from. So they might have an open door out to the street that comes through the shop and then out through the exhaust. Really, that's not an acceptable way to supply air to a cooking area. If you've got a busy street outside with lots of traffic and fumes from cars, and you're bringing that air through into a place where you're cooking food for people to eat, I don't really think that's acceptable. So basically, the air needs to be clean. You might need filtration. Sometimes you might be in a dusty area, so you need to filter the dust out of the air as it's coming in. But other acceptable areas, if you're in a hotel, say, where you've got a cooking area and you've got a restaurant around it, transfer air from the restaurant, should be quite acceptable, because the restaurant area would be air conditioned, or other adjacent enclosure. You can't draw makeup air from an enclosure ventilated by a required exhaust system or car park. Again, required exhaust system is a defined term. It means that AS 1668 Part 2 requires an exhaust system for that area. So you can't use that as a makeup. Now, as I mentioned, quite often outdoor air is ducted directly to the exhaust hood and supplied into the kitchen area. So this can be done in a number of ways. If you're using an alternative design, a proprietary type kitchen exhaust hood, quite often they are supplied with supply air facilities as well as exhaust air. So you've got a section where air is supplied in, it goes straight into the hood and gets exhausted out. So that's providing your makeup without using air from the room. You still require a bit of makeup to maintain a negative pressure. And you can use evaporative cooling. Sometimes that's done, but you can really only do that if your kitchen has got a roof over it, and you can put evaporative coolers on the roof above the kitchen. Otherwise, it's not really feasible. The outdoor air is often preconditioned to prevent additional heat load being imposed on the kitchen area. So you might have an air handling unit with a cooling coil providing conditioned air into the kitchen so that you're not putting additional heat load in there. So another requirement is, if an exhaust system requires a mechanical supply system, then they must be interlocked so they always run together, and that's obvious. If the exhaust fan starts, the supply fan has to start as well. Now, exhaust air discharges. Clause 310, for type B effluent greater than 1,000 litres per second, the effluent is classed as objectionable. There's non-objectionable and objectionable discharges defined in AS 1668 Part 2. We'll just go back to there. I don't know whether you're familiar with those terms at this stage. Go down to 310. So they're quite important to be aware of. 3.9 talks about combination of exhaust systems. I think we've covered this before, of what you can, exhaust systems that you can combine. So that's a table that tells you what you can and can't do. But air discharges. So here this table says objectionable effluent discharges. Type B, greater than 1,000 litres per second. When you're doing a commercial kitchen, it'd be very rare to have a kitchen exhaust system less than 1,000 litres per second. So this is always probably going to apply. If it's less than 1,000 litres a second for some reason, if you're just exhausting from one small piece of equipment, then it would be deemed non-objectionable, and you can follow this set of rules. But generally, we're talking about objectionable discharges, which is clause 310(3). Just while we're here, I think I've mentioned this table to you before, and you should be familiar with this, table 3.4, minimum separation distances from discharges to intakes. We're not talking about kitchen exhaust at the moment, we're just talking generally about, say, a toilet exhaust and an outside air intake. And this is particularly helpful for small jobs, where you have, instead of having to separate your exhaust by 6 metres, that distance can be reduced depending on the airflow rate. Are you familiar with that table?
Yep.
Well, yeah, it's another one that's important, and you'll refer to this again and again. So if it's less than 200, you can have them as close as a metre apart. Particularly applies with apartments and small buildings. Okay, discharges deemed objectionable. Air discharges that are deemed to contain objectionable effluent, which is what we just said, greater than 1,000 litres a second for type B. They need to be arranged vertically with discharge velocities not less than 5 metres per second. Then it talks about type A. We won't go into that. We will have a look at concessions. So if we just read through this one, number 1, where it can be demonstrated by reference to results of independent testing that special odour filtration processes will remove the odour contamination from kitchen exhaust air streams and prevent exhaust operation if these filters are not in place. Horizontal discharge of kitchen exhausts with airflow rates greater than 1,000 litres a second may be acceptable. This is something that comes up quite often. If you have a cafe or restaurant at ground level with in a mixed-use building where you might have apartments above or offices above, and this is quite common. If you go into the city, you'll see multi-storey buildings with restaurants at the ground floor. It can be quite difficult to take the kitchen exhaust duct all the way through the building, particularly if the building is redeveloped or a tenancy changes and they put a restaurant in the ground floor, but there was never any provision for kitchen exhaust to rise up through the building and discharge at roof level or in clear space at a high level. So we do this quite often, and I think, Jess, you might have done something similar to this recently. Is that right? Horizontal discharge?
Sort of. The air is HEPA filtered, so I don't know if would it still be classified as objectionable?
The exhaust had HEPA filters. Did you say?
Yeah. Yeah.
Oh, okay. Well, as long as it's able to, it's got to reduce odour as well. HEPA filters generally won't reduce odour. They will take out particles and they would clog up with the grease as well. So they probably wouldn't be very effective for long. But there are special products available on the market. And that there are special exhaust hoods which include these processes which remove odour and grease from the air and allow us to discharge horizontally. So normally that would be a special kitchen exhaust hood, but it can be done. That's basically all I'm saying. And you can talk to people like Stoddart's who manufacture exhaust hoods. They make these things. And air and odour management are a couple that I've worked with in the past. So this can be done, and it's just a matter of working through the process. Okay. So there's a lot in this, and I can't go into too much detail, and you're not working on one right now, but when you come to it, you'll have to work through this process. Now, AS 1668 Part 1 has some more requirements. It refers to commercial kitchens and not intended to apply to domestic installations. Quite often, kitchen exhaust systems are used to assist required smoke control systems, and the following requirements will apply. The kitchen exhaust hood system from separate fire compartments can't share the same riser shaft. So you have to have a separate riser shaft for the kitchen exhaust if you're going up vertically through the building. And they can't share the same shaft as the smoke exhaust system. So they've got to be kept separate. It can be a pain, but that's the way it is. You just have to do it. You've got to put in a separate riser shaft for kitchen exhaust. You can't have fire dampers in kitchen exhaust systems. That's really important because they do quite often operate in a fire situation as a smoke exhaust. And if they have fire dampers, the fire dampers could close and then the exhaust system's not working anymore. So you can't have fire dampers. And you can't have fire dampers in smoke exhaust systems, the same reasons. The ductwork must be constructed of 1.2 millimetre thick galvanised steel or not less than 0.9 stainless steel. We normally use galvanised steel because it's much cheaper. It's about, stainless steel is about 4 times the cost of galvanised steel, so it's pretty rare. And it's not necessary in this case to use stainless steel. The exhaust is generally not corrosive. It's grease, so it's, it tends to preserve the duct if anything, but that's a requirement, 1.2 thick. So be aware of that when you're doing drawings or if somebody asks you, what do we need to use? Ductwork shall be installed vertically wherever possible. So ideally, the duct goes up through the building or up, if you've got a roof over the kitchen, straight up through the roof. And that allows any grease in the duct to run back down into the hood and then drain into the gutters of the hood. If you have horizontal ductwork, try and have a rise of, they say, 0.5% in the direction of flow. So it's going up. So grease will tend, when it's hot and fluid, it will tend to run back to the exhaust hood. And these are all requirements out of 1668, so Part 1. Access is required for cleaning inside the ductwork at each change of direction and every 3 metres or less. So within every 3 metres of, now that's of horizontal ductwork, okay? In vertical ductwork, you don't have to have access panels, and quite often it's built into a riser anyway, so you can't get to them. But the idea is that with horizontal ductwork, you need to be able to get in there and clean it out every so often. You have to have a drain plug at the lowest point of each run of duct. Now these points, I'm bringing these up specifically because if you're drawing the kitchen exhaust system, you need to be aware of all this. And you can go to 1668 Part 1 and have a look, but these are the things to be aware of. So if you've only got one riser going up, then you'd have one drain plug. You may not need it. If you're coming off the top of an exhaust hood straight through a roof, if the roof's over the kitchen, you're going straight through the roof to an exhaust fan, then you won't need a drain plug because any grease will drain back into the hood. But if you've got a bit of horizontal duct and then you go up, then you'll need a plug at the bottom of the riser. Now this next one is an interesting one that, to be honest, not many people take too much notice of it, I don't think, in my experience, but it says that ductwork within the kitchen area shall not be closer than 300 millimetres to any combustible material. Now, that could be electrical cabling, for instance, and if you've seen installations on site, an electrician may have loose wires running through the ceiling space, and they might be resting on top of the kitchen exhaust duct. So that's potentially dangerous if the ductwork gets hot and starts to melt the wires. There's risk of electrocution or even fire. So I don't think there'd be too many jobs where you can achieve a 300 millimetre separation between the metal and a combustible material. So if you can't do that, then it needs to be externally insulated with 20 mil thick fiberglass or rock wool. So that's something to be aware of when you're drawing kitchen exhaust duct within the kitchen area, within the kitchen compartment. In the ceiling space, it needs to be insulated. That's the easiest way to get over this problem, just insulate it with 25 thick fiberglass. Now, that doesn't get done very often, so be aware of that. And fans and cowls shall be manufactured from materials that have a fusing temperature greater than 1,000 degrees. Basically, that means steel. Okay, you can't use plastic fan cowls or plastic fans. They must be metal. Now, going on to fire mode operation, again, we're still talking about AS 1668 Part 1. And these are requirements. You probably haven't had a lot to do with fire mode at this stage, but just so you know, because this will come up time and again. If there's a fire alarm and the kitchen exhaust fan is operating, it must continue to operate. So you don't switch it off, you keep it running if there's a fire. If there's a supply system associated with the exhaust, that can stop because that will help to create a negative pressure in the kitchen area. Kitchens are probably one of the major sources of fires in buildings for obvious reasons. You've got flame, you've got heat, you've got grease, and you've got air. So you know it's a potentially dangerous system, and by allowing the kitchen exhaust fan to continue to run in fire, you're helping to take the smoke out anyway, so that people can escape safely, which is the main purpose. Control and indication on the fire fan control panel is only required if the kitchen exhaust system forms part of the building's fire and smoke control strategy. Now, this might not mean much to you, but the fire fan control panel would normally be located next to the main building fire indication panel. So the fire contractor puts in a main, what's called an FIP, or they call it different things, but fire indicator panel is when you go into a building, you see a panel there with all these switches for and fire alarm indication lights. So the fire fan control panel may be part of that or next to it, and that's controlling any fans that have to run in fire mode. So it might be smoke exhaust fans, stair pressurization, and so on. And the fire brigade has access to those fire fans. They can switch them on or off, and they've got indication to show that they're running or not running. So you don't have to have that indication and control on that panel unless the kitchen exhaust system is part of the fire and smoke control strategy, which we may come up with for a building. A consultant may provide this information. Normally, a consultant should specify what they want to happen in a fire mode. If there's a fire alarm, which fans are required to run, and which may not. So if there's a kitchen exhaust, they might say it's not part of the strategy, but we still want it to run in a fire. Does that make sense? It'll make more sense when you get a job which has one.
Is that information all in like a fire matrix?
Sorry,
Like
Jordan,
where,
can
where
you
does
say?
that information get given to us?
Oh, okay. It would either be in a fire engineering report. Most projects or most larger projects have a fire engineering report, which is produced by a fire engineer. Have we talked about, we haven't talked about fire engineering reports, I suppose, have we? We will come to that a bit later. So they would define whether the kitchen exhaust system is required to run in a fire. But if you have a specification, if the job is designed by a consulting engineer, there should be, and if there isn't, you need to request it. There should be a description of how the systems are to operate in fire mode. Okay, so it should be specified. It'll be in the specification. If it's a design and construct and we're doing it ourselves, then we need to come up with the fire strategy. And that's not an easy task, but and it's probably not something that you would be doing very often, I wouldn't think. If you've got a job of this size, which has kitchen exhaust and a fire control strategy, it's a much larger project and would probably be designed by a consulting engineer. Does that answer your question?
Yeah.
Okay.
Yeah.
There's just a note there that kitchen exhaust fan isolation switches have labelling requirements. That's in 1668 Part 1. Now, the kitchen exhaust fan, if it's located in a fire compartment outside the kitchen area compartment, which it normally is, so the kitchen exhaust duct comes out of the kitchen. Let's say it's a multi-storey building. This is probably what I'm talking about. So the kitchen exhaust duct will run horizontally out of the fire compartment, and then there may be a plant room next door, or there might be a plant room somewhere else in the building. But if it's next door or anywhere else, it's going into a different compartment. And so the kitchen exhaust fan would have to be located or housed in a fire-rated enclosure. And any ductwork outside the kitchen area may have to be fire-rated as well. You just have to look at the fire compartmentation, which will be on the architectural drawings, and then determine what you have to fire rate and what you don't. I'm a bit vague on this because it varies from job to job. I worked on was a hospital actually in Sydney, which had a large commercial kitchen. Adjacent to the kitchen, there was a plant room which had the kitchen exhaust fan plus other air conditioning equipment. And the initial design, well, there was a firewall between the kitchen and the plant room. So everything in the plant room on the kitchen exhaust side had to be fire rated. But then there was a fire engineer who came in and did some analysis and wrote a report and said it doesn't need to be. So in the end, we didn't have to fire rate it. So this is where the fire engineers get involved. They can do an assessment, or what their job is to do an assessment of the fire safety of the building, and then come up with recommendations. So they might change the requirements of the NCC, for instance. NCC might say you need to do 1, 2, 3, and the fire engineer says, well, we're not going to do number 2. Instead of that, we're going to do something else. And the aim of what the fire engineer does is to try and, well, they model a fire in a building. They model a typical fire. They've got software that can, go through it and look at different scenarios. And for instance, they might say, they might ask you to put in stair pressurization in a building that doesn't require it by the NCC. Or they might say, well, the NCC does require stair pressurization or smoke exhaust, but under my modelling scenario, you don't need it because we're going to do something different, which might be sprinklers or it might be an electronic fire alarm system or something else. So that's just by way of clarification, but we'll talk about that another time. It's common to house kitchen exhaust ductwork in a riser with no other ductwork, which I mentioned before. So provided, I've left a bit out here, provided the riser is fire rated through the building, as it rises up through the building, it would need to be fire rated, then you don't need to fire rate the kitchen exhaust duct. But if it's not a fire rated riser, this can be a bit contentious. It needs to be looked at very carefully. If it's not a fire rated riser, then the kitchen exhaust duct has to be fire rated. But we won't go into too much detail because it's not relevant to you at the moment. Now, just a few extra notes. NCC Volume 1, Section J, fan and duct systems, doesn't apply to kitchen exhaust systems. That's an exclusion, a specific exclusion. You're probably familiar with the requirement for ductwork to have a pressure drop less than 1 Pascal per metre. So when you're doing your static calculations, you've got to take that into account. That doesn't apply to kitchen exhaust systems. And that's a specific exclusion in the NCC. It's customary to design kitchen exhaust ductwork with an air velocity around 8 metres a second, with the intention to ensure that grease vapours are carried through the duct to the discharge point. If you have low velocity systems, the grease is going to drop out of the air and start to build up inside the ductwork. So higher velocities will carry it away. Firstly, you've got grease filters. That should be taking the majority of it, but some grease will get through, and we want to make sure that we take it out and not build up in the ductwork. And again, as I said earlier, we're not talking about low airflow rates. We're talking probably minimum 1,500 litres per second and probably quite a bit higher than that. So 8 metres a second doesn't have a huge pressure loss per metre anyway. Obviously, for a small airflow rate, it would. Flexible ductwork can't be used in kitchen exhaust systems. Now, that example I gave you earlier where the kitchen exhaust was discharging into the room next door or into the ceiling, that had flexible ductwork on the kitchen exhaust. You can't do that. It's got to be, as I said, 1.2 millimetres galvanised steel, solid duct, and cleanable. You can't clean flexible duct, and it's not robust. So it's just, don't even think of it. If you've got a proprietary style exhaust hood, which has exhaust and supply, then the supply air connecting to the hood can be flexible because that's an outside air makeup system. And that's just like an air conditioning system. It can be a flexible duct, but not on the exhaust side. Avoid using turning vanes in kitchen exhaust duct elbows to prevent grease deposits. Turning vanes are quite often very close to each other and very small, and the grease in the air will get trapped on those turning vanes. So don't use them. Use radius bends. Now this is what I was talking about earlier as well. Horizontal discharge of kitchen exhaust with a flow rate exceeding 1,000 litres a second may be accepted, provided special filtration for the removal of smoke and odour is provided. So we won't go through that again. It's just something to be aware of, and it's done quite often. Proprietary kitchen exhaust hood designs normally specify lower exhaust airflow rates. I mentioned this earlier. Lower airflow rates than you would get if you use the prescribed calculation method, but they are a lot more expensive. And normally we wouldn't offer those as contractors, or your clients' contractors wouldn't offer them. They would offer a standard kitchen exhaust hood because they're much cheaper and they can be made by anybody. The proprietary ones are special products, generally of an international design, not necessarily an Australian design, but manufactured in Australia and tested so that they're acceptable. They have to be tested and approved by the authorities, and you'll find that the ones that we deal with, the Stoddart's brands and the AOM, have all been tested. And they have significant benefits to the mechanical contractor. You can have a reduced exhaust fan size because you've got a lower exhaust flow rate, reduced exhaust duct size, reduced makeup air requirements, reduced capital cost, and potentially reduced energy costs. One of the difficulties with a conventional kitchen exhaust system is the high airflow rates. So even with the 8 meters per second exhaust velocity, we can finish up with very large ductwork, and it's hard to fit it in sometimes. If it can be reduced, it has all those benefits. So yeah, just a comment at the bottom there. The proprietary hoods are generally more expensive than conventional. I'd say in all cases they're much more expensive, and normally procured by the builder or specialist kitchen installation contractor. Some projects do have a special kitchen contractor who supplies and installs all the kitchen cooking equipment and would also provide the hood to go over the kitchen equipment. And that's installation of the hood maybe by the kitchen contractor, but quite often by the mechanical contractor. So they'll deliver the hood to site, and the mechanical contractor will install it and then connect the exhaust and supply to it. So if that's the case, you need to request from the builder details of that hood, which will have drawings of the hood, where you connect to it, and the flow rates for exhaust and supply. It's a very large topic, obviously, and if you have a job with a kitchen hood, you need to determine what cooking equipment is being exhausted. Go to AS 1668 Part 2, find that cooking process, have a look at the appendix, what sort of hood do we use, do the calculations. They're not difficult, but it's just a process you need to go through. Unless there's a proprietary hood being provided, then you need to get the details and work to that. Any questions? No.
Yeah.
It's there's quite a bit in it, and but you will get to do some of these, I'm sure, at some point. And I thought it was worthwhile talking about it now because it could come up any time. Any job might have a commercial kitchen that you need to provide an exhaust system for, and you need to know how to go about it. We'll give you a bit of an introduction to it anyway. Okay, well, we'll leave it there if you've got no questions. Next week, I'm proposing to talk about economy cycles and energy recovery ventilators. So I'll send out some notes on that, and we will see you then.
Sounds good.
Sounds
Thanks,
good.
Peter.
Okay, see you guys.
Cheers.
Have a good week. See ya.
Bye. Bye.
See ya.
Oh! Did I share it to you? Fine. I only had one. Whoops. Okay. That's okay. How's the week? And you came in? Um, so- um, I basically copied the wedding band songs a bit. I need to like delete a whole bunch. Let me quickly delete. It's yeah, right. These are all the same thing. Linguini, okay? Why? After the response comes in. I see skies are blue. What? Oh. No.
What question do you have?
When I asked you, rather but then I have to buy.
Oh.
Yeah, I'm gonna get the bulk of this. And, you know, you people. Did we throw out the table?
Why? What the fuck are you doing?